Hello and welcome. In this video, we're going to take a look at Python's classes, and particularly the methods and attributes that we created before in previous videos, and how can we make sure that they are kept consistent and reliable so that we can count on them when we need them. And to exemplify this, let me pose a problem to you. Last time we created a class of dog, so let's do that. We've been using this class for a couple of different videos now. And in class dog, we're going to pass in object. And inside that class dog, let's set up our constructor function. And we'll pass in self, name. Yeah, we'll just do self and name for right now. And then let's do self.name equals name. And yeah, that's fine. Let's set up a print statement beforehand to let us know that we've created one. Let's do print. Hello, I am new here. Okay, so we have a class dog, and now let's go down and set up our new dog. So we'll do dog1 equals dog. And we'll have to pass in a name. So this name, we'll set it as, we're using Fred. All right, so we have class 1 dog Fred, and now we can do dog1 dot name, and let's print that. All right, so we have the ability to see the self name that we've defined within. Now, what if we wanted to actually protect this name? Why would we need to protect it? Well, watch what can happen. So if we go to dog1 and we do dog1.name just as above, and we do equal, let's change it to Lassie. And now let's print dog1.name. So we've just changed the dog's name using dot notation. We go, instead of printing it out, we've actually gone inside the new object, the dog1 object, and we've changed that property from the outside. We haven't done it inside the class itself, but we've now changed it through the outside. I mean, we do this already when we pass in self and name, we pass in that parameter, name gets assigned to self.name. So this property is accessible and can be changed from the regular program itself. This is desirable in a lot of cases, but in other cases, you're not going to want the program or anything to be able to affect that class name, be able to maybe even see that name. Maybe it's something just used locally inside of the class and doesn't need to be accessed or used. Computers don't know what things should be private or what things are limited to certain areas. Okay, we as humans write programming languages to try and contain the chaos that can happen when you're trying to enter stuff into a computer, right? So when we try to do this, when we write out our objects, we have to be cognizant that some things are best left unknown to the regular program, and we can hide things. We can keep things secret from the regular program, from what the rest of the computer is processing, because maybe it doesn't need to know those things at that moment, and maybe as a programmer, I don't need to know dog1.name later in the program, or if I change it later in the program, maybe it's going to mess everything up. There's certain things about objects that we can't change. Maybe they're constants. You know, if you have a car, let's say, and it has a make, a model, a year, and mileage, you can't change those things. Well, you shouldn't be able to change those things. You have a birthday. Your birthday throughout your life should not change. The year you were born should not change. So these are some things that we're creating here that should not be able to be changed. So we can do that. We can do name and year born, or say birth year, and we can do self dot birth birth year equals birth year. So we'll pass that in. And now we can pass in a number. Maybe this dog is this is an old dog, 10 years old. Born in 2010. Dog1.name. There we go. Missing one required positional argument. Dog1.name, birth year. Oh, I did it the wrong place. Up here. There we go. Okay. And so then, same thing, if we're not changing the name, maybe we would do dog1.birth year equals 2005. So it depends, right? So then we go print dog1.birth year 2005. So we've changed, and maybe the record's wrong, and maybe we want this to be changeable. Maybe in case of an error. But there are certain. My point is that there's certain things that exist that are constants and should not be. Maybe they can be seen in the program, but maybe we don't want them to be changed in the main program. So how can you control the computer in such a way to allow it access to certain things, but not everything inside of your program? So I'm going to get rid of all this just to clean up the code a little bit for you. And we're going to do something here. We're going to create what's called a private attribute, an attribute that is limited in scope to just the class of dog. So let's take that birth year and make it so that it's now private. And to do that, it's actually really easy. All we need to do is we do self dot, and then right before the birth year, we do 2 underscores. And what that does is that now makes this private. And what does that mean to make something private? Well, let's try to print it and I'll show you. So dog1 equals dog. Should have left that. Fred 2010. And now let's print dog1 dot birth year. Interesting. So it says dog1, we created hello, I'm new here, traceback problem, dog.birth year. Attribute error. Dog object has no attribute birth year. How is that possible? I thought we just created a birth year. I passed it in just 2 lines above, 2010. It's in the program. It didn't throw an error when we try to add this in. We can't just toss stuff in here extra. See, Python doesn't like it. So it takes 3 position arguments, but 4 were given. You can't just toss stuff in here when it's not used inside the class itself. So it's not like we just gave the class something that it didn't need and it just took it. It did take it, and it even when we were filling this out, it tried to autocomplete. I don't know if you saw that. See, it even says it tries to autocomplete for us. It gives a little hint of what can go in here, birth year. But then when we try to access later on, it says, sorry, can't find it. So why do we do this? Like I said, there are ways to use this inside the program. There's no reason why we can't do part of the constructor, something like print I was born in, and then there's no reason why we couldn't do birth year. Do the double underscore birth year, and let's see what happens. Oh, I tried to call it again. Let's do dog1. Let's just do that. Oh, I'm gonna comment that out. It's gonna print out anyways. There we go. Hello, I'm new here. I was born in 2010. So there's no reason why we can't use this inside of the class itself. It's just that you can't access it inside of the main program. So this is helpful in trying to limit. We can set up methods. We can set up things that we can access and print stuff out to us or return stuff to us, but we get to control how that is being accessed by the computer. We keep secrets from the computer itself, essentially, when we write these programs. Now, in full disclosure, there is a way around it. So this is, it's meant to discourage the use of getting access to private methods or private attributes from the outside main program. But there is a way to get access to it. And if we just simply do it by, we can do, let's see, instead of birth year, we can do dog birth year. And by adding in the class and by adding in the double underscore there, we can technically find a backdoor in getting access to that value. So what good is it, right? I mean, if there is a way in, what good is it? And the truth is that the most people are that when they encounter that, it requires extra effort to go in and put in the extra class and the double underscore. And not much effort, but a little bit of effort. And if you're writing lots of code and you just quickly you enter the mindset of okay, dog one dot birth year, and it says no attribute found. People's when you're debugging your code, you might want to find out if it actually is there, and maybe you're just doing something wrong with it. But really, it's there to discourage people from actually using it. There are ways to control access to it, but I wanted to show you that just in case you come across it, or if you look it up online and say, "Well, this guy's a liar." There is a way in. Um, there is a way in, but by and large, it's mainly meant for like emergency, like critical need, like finding out exactly what's wrong, type of solution, not for like every day just writing a program. Okay. Now we create a private attribute. We can also create a private method as well too. And for that, let's set it up in our constructor method as well too. Sorry, not in the constructor method. We'll do it right below the constructor method. So I'm going to back out, make sure that I'm a tab back, right? And let's set up a define. Let's do it as public method. Actually, we'll do define private method, and I'm going to do it as the two double underscore, just like we did above. Private method or private function. We pass in self. We can do print. This is a private method. Okay. Let's go down here and let's print. Actually, let's just do, yeah, actually this has a print statement already. We can just do dog1 dot private method. And this could be named anything. It doesn't take any parameters, but this should print out this is a private method. But it doesn't. It says, oh, it's still the birth year thing. Hang on. There we go. Dog object has no attribute, private method. All right, let's do something else. Let's go below here and let's do define public method, pass in self, print. This is a public method. And let's go right below it, and let's call the private method. So we can do self dot double underscore private method. And what this will do is it will run this one above here. So let's see what happens here. Oh, it's still going to not be happy with us. Let's comment that out. And all right, so we see nothing happening here. Let's go down to the next line. Let's do dog1 dot public method. And this should call, this is a public method, and that should print that out. But then it's going to call the private method. Let's see what happens here. All right, so we see it call the public method, and it goes up and calls, it goes under this line, calls a private method, which then prints this is a private method. So it's showing that a function, a method inside of a class can access other things inside that class, but the outside world cannot. And this is what we meant by public versus private. What can be seen inside of a class and what things should be seen, what things do you want the rest of the program to see, versus what do you want to just keep contained inside, just private for itself for internal use only. And when are you going to use this? When are you going to see this? When should you implement privacy? Well, there's a couple of places that you might see this. If you study game design or practice game design, a lot of other languages require that you say whether something's private or public, or at least offer it. And so it's pretty common in things like game design, simply because there's so much code and so many different places that code is written, that you can sometimes get conflicting variables. And so if you're only going to use a variable one time inside of a class or one time inside of a place, then just do it and make it private. And that way it's for like internal use only of the class, and it's not seen by other things inside the program. Other code can't see it. Basically I would say if it's all only internal, use it then. You want to create stuff that reduces the need for other clients, other things to get access to it. So by default, should you have more private methods or more public ones? I would say you should probably have more private methods and attributes to keep things contained inside the class, and you'll run in with less code errors later on. So I'll make a comment up here about this is a private method or function. Same thing. Okay. So the last thing we'll talk about with classes is how maybe you don't want to just deny outright access to something. Maybe you want to be able to control the fact that maybe you wanted them to be able to see a private attribute, but not be able to uh, change it. You don't want write access. You don't want them to be able to overwrite your existing code, but maybe you just want them to be able to see it, or you want to provide a very specific way that they can modify it. So let's talk about controlling attribute access. That's the next thing. So how can you control it? Well, what we're going to do is go to, after our public and private methods, we'll keep Fred there because I'm going to use them again. And let's have a way of controlling the name. So up at the beginning, we did self-name, self.name, right? What we're going to do is we're going to create a new class. And we'll keep self.name. We'll make name private. So let's double underscore in front of self.name there. So now name is private. Okay, so let's provide a way. Let's control access. And we'll control access with what's called a setter. We'll talk about this. And let's define a function called name, pass in self. And what we'll do is this, we'll just have self return self dot underscore name. And so right now, this is technically a public method. Anything can see this because we did not double underscore in front of name. But we're going to add in one thing in front of it, just like before. We added the at symbol. What we're going to do is we're going to add at property. And that's going to make it fairly specific in terms of what can actually access this. So the property decorator is going to be allow indirect access to the method. The method that, or the function that immediately follows the decorator property or the keyword property. You can use the name. You can now use the name property of any critter or any dog object to get the value of the object's private name. So let me show you what I mean here. So we can do dog1, let's see, dot name. And this will report back to us the name. So I'm going to print this out because this value of dog1.name is going to be set by return. So let's see what happens here. String1 not callable. Dog1.name. Oh, whoops. What we want to do here is actually, we don't need the parentheses here because even though we added the defined property and the name is a function here, when we add the app property, it allows us indirect access to the name attribute. So here we see Fred. So how do we get access to Fred, dog1.name, if it's private? Well, we name a function the same name as the attribute we want. We add the app property at the top of it. And we can now get access to self.name. And what essentially we've done is if we try to change it though, say dog1.name equals lastly, like we did before, it'll say can't set attribute array. So we're saying we can't change that because it's private. But we can access it now because we added this little thing up here to allow us access. So that gave us essentially read access. We can read that property, but we can't change that property. So actually, we'll go up here, control access, read access. That's what that does. Control access, write access. So we can control the basically the ability to write over that method by doing similar to above. We add a decorator, but this time we get the attribute name, we add dot, and then we do setter. Oops, no, there we go. And setter is a function that's built into Python that in a lot of languages will have getters and setters. But a setter is going to allow us to access to that. So what we can do is we can do actually app property. I'm going to comment out the app property above there. And because I'm going to use define name again. And this time I'm going to do self and new name. And if new name equals a blank string, basically they didn't type in anything, we're just going to do print, please enter a new name. And then we can do else self dot double underscore name equals new name. Then we can print name change successful. New name is, and then we can add it. Add self dot double underscore name. All right, so name dot setter undefined name. What? Oh, you know, whoops. So we're going to need the property attribute, because that's right. So actually, well, yeah, see, no, in a way. So we actually need to uncomment the property attribute. My initial instinct was that define name was going to run into a conflict down here, but I forgot that actually the name setter we're running on the property. We're not running it on the actual like variable above, the attribute above. So here, it's not going to cause us any problems, because essentially what we're doing here is by setting a property define name, it's giving us access to that, indirect access to that private method. And then what we can do is we can go into that and actually add another method, built-in one, like I said, setter, that will essentially redefine what name is going to be, and it's going to allow us to input something as a replacement for the name. To give you an example, I mean, so all right, so just to reiterate here, the name setter is changing the indirect way to access that attribute. So like think of like the attribute as like the most base, like a private element of this entire class. The at property decorator is going to give us access to that private one, and then at setter we can go and change that. So you can see that it actually there's a way to write it in your code that it might seem like more difficult than just like going and like making it public. But what you're doing is you're providing ways to change it. So why couldn't I just do, if this was public, I could just do dog1.name, it's just blank string. Well, I don't want that, right? I don't want to have a dog with no name, and I don't want to have a dog with no birth year. So what I would do is through a setter attribute, I'm going to show you how this works in just a second. We can change the dog's name, but we control what can be entered or what happens if there's, say, a blank string and there's no name entered. We say, enter a name. Otherwise, we say you can rename it. So it's just protecting your code against other programmers and possibly yourself. So yeah, it requires a little more, but if you're writing, a program that has 1,000, 1,000,000 lines of code, you're going to thank yourself later on if you control access to this and make sure that something doesn't accidentally override a value that you actually need. Now, one last thing I'll say about it is that do you have to have, so we use name for all of them, right? So we used self.name. Notice the name was the parameter being passed in here. Self.name is the attribute it gets assigned to, so name gets assigned here. So in this case, we defined name, and here we see name again, and we see name again. So does it all have to be the same name? The answer to that is kind of. The at property, the defined name, this and this have to be the same. So once we define the property of name, And this name, this has to be the same thing because this is essentially is getting this right here and adding a setter to it. Okay, the other thing we can talk about is can you actually go and change this stuff? So I can show you here. So let's do define name. Let's see what happens if we change this thing. Let's say get name. That's what that does. We see an error down here. Undefined name. So this has to be the same as that. So get name. All right, does that work? That seems to work. We do set name. That's essentially what that's doing. So we see here, we run it. Dog object has no attribute name. So in this case, it is, let's see, it's down here. So let's do dog1. Let's see, get name. That work? Okay. Fred. All right, that seems to work, right? Get name, self. What happens if we make it a method? Actually, let's see, please enter a name. Name change successful. Making sure that I'm not printing out his name anywhere else. Okay, yep. All right, so can we do that? Dog1 dot get name. Whoops. So we can do this where we let's do actually dog1 dot name print dog1 dot name. Gonna yell at us. Yeah. Let's do dog1 dog name. Okay. Let's do dog1 print. Actually, we'll just do dog1 dot set name. We could pass in a parameter of Lassie. String object's not callable. Yeah. So here, what's happening? Can we go and can we change, maybe not that way, but can we do dog1 just dog1 dot name equals Lassie? And then dog1 underscore name. Can we do that? Okay. So here we see, does this matter? No. Traditionally, what you would do is you would name this property. This, we call it a getter, right? You would define this as the same name as the thing you're trying to get, just to keep things clear and consistent. But there's no reason why you couldn't name it get name, and it will return that variable for you and as a read access. And up here, we're using that access to add a setter to that, and we define set name. So there's no reason why, and like I said, set name is going to add a new name. So it's just more confusing, I think, for you as a programmer maybe to write it this way. Let's change it back to the original. There's no reason why. Just do name, name, and name. And let me show you why I would recommend this way. And let's do print dog1 dot name. And let's see what happens here. I can add a little space there. Okay, and let's do this. Let's print it out. All right, so originally when we created our dog1, Fred, 2010, we print out the name here. We expect the name to be made, and then here we changed the name. And so we did dog1 dot name Lassie. Now, what happens if we did dog1 dot name equals empty string? Name change. So name change was successful. Let me comment that out. Please enter a new name. We can say, please enter a new name. Name empty. Please enter a new name. And then we say name empty, please enter a new name when we try to enter an empty string. If we tried to do this originally, we would just be able to enter an empty name and there wouldn't be anything there. So with a couple more lines, what is this? 3 and then 6, so 9 extra lines. You have now controlled read and write access to this property, this private attribute, so that it cannot be modified without your permission. Okay, and so how many of these do you need? Like I said earlier, how many should you have? There's no law on how many of these things you should enter, but basically, think about it as you should have as many as you need to keep private, and otherwise you're going to be writing. Something might have 10 properties, so that means you have to write 10 of these for each one, depending on what you need it to do. So it all depends on how big the program is, how many people are working on it. Do you need to do all this for like a 30-line program? Probably not. But if you're collaborating with other people and you're going to be opening it up for other people to put in data and work with your program, then there's no, you're probably going to see a lot more of this. I don't know why that went up a line there. There we go. You're gonna see this a lot, just because, and you're gonna see it in different programs, and all it's doing is just controlling access to that class to make sure that something doesn't go wrong along the way. So that's it for this one. Thanks for watching. I'll see you in the next one.